All right, well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. As always, we have a great event on tap. This is going to be a great one. I just love this title and this topic. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for any of our speakers, please don't wait, don't hesitate. Just use the question and answer tab there on your interface and submit your question, and we will try to get to as many as we can near the end of today's webinar. We also have a very interactive chat feature, so I do encourage you to chat us your questions, comments, suggestions, whatever you want to share with us. We will be more than happy to take it, and we might even chat you back. And then finally, at the end of today's webinar, we are doing a drawing for 4 $100 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Securing Your IoT Software and Infrastructure Got You on Edge. Our speakers today are Steve Chappell, who is the the solutions architect and software security evangelist at Synopsys. Hi, Steve. Welcome.
Thanks for having me today.
All right, great. We also have John Senegal, who is the principal solutions architect at Red Hat. John, thanks for joining. Great to see you.
Good to be here.
And then finally, we have Cody Richard, who is a global partner solutions architect at Red Hat. Cody, thanks for joining us today. Really appreciate it.
Thanks for having me.
All right. Well, Cody, I know you are going to be kicking off our conversation, so I'm going to just put myself on mute, hand it over to you. I will see you guys at the question and answer period.
Great. Thanks so much, Charlene. Hi, everyone. As mentioned, I'm Cody Richard. We have John Senegal and Steve on the call, and we're going to be discussing some IoT, securing, and edge infrastructure stuff with you guys today. So I want to just start with a brief overview of Red Hat's hybrid cloud infrastructure. And so this has remained the same for the last 10 years. We haven't really ever changed it. We were one of the leading pioneers in this space because we recognized in the past that it was going to be something very large in the future. And we've kind of come up with a couple different enduring principles of our open hybrid cloud. We have that consistency of a customer experience across all of application platforms. We have flexibility of deployment across hybrid, multi-cloud, or on-prem environments, while also ensuring you have your open choice of software, as well as access to the latest innovation and reducing risk with reliability and trust. So I'm going to switch to the next slide here. We bring all of these together to address the needs of diverse use cases through an edge platform that's adaptable and provides customers with the peace of mind that they can develop once and develop anywhere, while also maintaining consistency in operations and application development. From smallest compute footprints and IoT gateways, smart displays, and vehicles, to cost and resource efficient Kubernetes on bare metal clusters driving smart factories and retail stores, as well as to Kubernetes deployment on third-party public or private cloud infrastructure. But what really is the edge space for Red Hat? We know that the edge can vary by use case, but here we have a kind of view of what we look at with our edge tiers. We understand that computing is now being distributed across multiple spaces within the IT ecosystem. We kind of start with our what we call provider or enterprise core, and this is the traditional non-edge tier that's owned and operated by a public cloud provider, telco service provider, or a large enterprise. And then we're able to scale out to the service provider edge, which is edge tiers located between the core or regional data centers and the last mile access, as well as commonly owned and operated telco or internet service providers and multiple customers. And then we finally have our end user premise edge. And this is the edge tier at the very far left of the screen. And you can see on the edge tiers that this is what we call the last mile. This can include the enterprise edge, such as a retail store, a factory, or train, or the consumer edge, which would include a residential household or a car. And so Red Hat has really pivoted our production of IT open source products to meet all of these different edge tiers. And so I'm going to discuss how we kind of do that with one of our products, OpenShift Container Platform. And so with OpenShift, we've now focused on 4 different edge architectures to develop and deliver a consistent operation at scale. We start with the smallest footprint on the device edge, which would run a single node. We also have these single node master worker servers, as well as remote worker nodes and 3 node clusters, which is more of what we see nowadays with 3 workers and 3 masters. And finally, I just want to discuss some of the different use cases that we see in very large industries. For example, in telecommunications, providers continue to see an increasing number of devices and bandwidth-hungry applications that all demand a seamless experience. And these telco providers must not only address this need for scale, but they must also look at the lower costs and create a new revenue stream. Some of these examples are virtualization of radio access networks so that they can quickly scale their software-based network functions and place them at the edge to help address the scale requirements as the number of mobile phones increase to meet increasing data demands, or even multi-access edge computing and use cases that create an opportunity for service providers to offer new services to enterprise customers so they can develop at large scale. With manufacturing, plants can proactively discover and solve problems before they occur by gathering and processing sensor data at the assembly line and enable the business to reduce downtime through predictive maintenance and improved product quality through edge analytics, where through IT/OT integration, you can extract data and integrate applications at the factory floor. And finally, with energy, in companies like oil, gas, mining, and industrial sites, you're able to monitor and control equipment, which allows you to take action in real time to avoid harm to critical infrastructure or worker safety. And this means that companies can help better support decision-making, which improves safety and delivers production optimism. But really, what else do we see with the edge? And I'm going to turn that over to John so he can discuss edge and DevSecOps.
Yeah, thanks, Cody. So I'd like to talk a little bit about, break the edge down into a little more detail here. So when you think about edge and IoT, this is a typical reference architecture. On the left, you'll have some type of data generators. These are typically sensors that exist in a car, on a factory floor, maybe a camera. And then next to it, connecting to it, will be some kind of gateway devices. And this is the multiplier. This is the kind of gateway devices that there would be hundreds or thousands of these things connecting to the sensors. And typically you do filtering and aggregation at this level. And then if you go to the next tier, this is an intermediate tier that may do some aggregation across all of these gateway devices, do some more filtering, perhaps some analytics. And then on the back end is your traditional kinds of applications that's going to do AI, ML kinds of stuff. And also down in the gateway, you can do AI, ML things as well. But this is a typical architecture when we talk about an IoT edge deployment. And if we break that gateway device down a little bit, that system that connects to the data generators, what you'll find there is that you have all of these elements that exist as part of that. So there's going to be hardware, there's going to be storage and networking, there needs to be some kind of OS or platform, data processing, maybe there's some AI model inferencing going on. There's going to need to be security and compliance. There's going to have to be operations as part of that. Also, a big part of that is application development activity. So when you are building out the stuff that goes on this device edge, there's application development that has to happen to make all of this software real and live. So just taking a look at a traditional IoT edge development cycle, what you'll find is that you have 4 different groups typically involved in these kinds of involvement. You have the IoT people, the people that understand how to get data off of devices, can speak all of the protocols that are necessary to talk to those devices. They have to code and build and test and release things. And in a typical development cycle, they then hand it off to the OT operation team. They're responsible for these device gateways. And so they're responsible for getting the stuff deployed and managed on those systems. But the IoT stuff that runs on the gateway has to talk to some back end. So there's a separate development team writing the back end code, putting things in the database, etc. They build, test, and release things and hand it over to an IT operations team who then deploys the stuff and manages it from there. So this is traditional development cycle for an edge IoT solution. But what's happening now in this industry is there's a convergence between these 4 teams as we move into the world of DevOps, where dev and ops have kind of converged to come down with a streamlined process to make delivery of code faster and easier. The same thing is happening in the edge IoT development world. There's a convergence of those worlds. And as Cody was talking about, Red Hat OpenShift, as we take our OpenShift platform and we push that platform out of the data center, out to the edge, all the way out to the far edge, where we have a platform now that can run on these gateway devices. So these devices that are out there connecting to sensors and collecting data can now run containerized workloads. So if they can run containerized workloads, just like you do in a data center, we facilitate the OT IT convergence here, because now these teams can merge, and the same tools, the same processes, the same technologies can now be used for both what's running out on the device gateway and what's running in the data center. At all 3 tiers, Red Hat OpenShift could run there. So let's talk about that, and let's explode that a little bit, that reference architecture that we talked about before, and the life cycle of getting code to all 3 tiers of that reference architecture. When you look down into it, and we now start talking about, instead of just DevOps, DevSecOps is now what we have to talk about, because now that we've moved out of the data center, and you have to talk about DevSecOps in the data center as well, but it becomes even more important as you merge these processes of how you get code out to the different tiers in this kind of architecture. Security becomes even more important. And so when we look at the process here and the tooling that goes into a DevSecOps process, you see there's an IDE and source code management, there's build automation, container registries, orchestrations. But at each one of these levels, there are certain security methods that have to be considered as you move your code through this pipeline. So there's identity access and vulnerability and configuration management for the IDE and the source code management. You see that identity access is spread out throughout the whole process here. And when you get to the orchestration, you see things like data controls and network controls. So all of this now needs to be considered not only just for the back-end part, but also for your edge IoT components as well. And so now when we dig into this a little bit, we see there are techniques that apply to these different methods. So there's source code scanning, there's static analysis that has to happen. So there's all of these techniques that address these methods. And what you see in this chart, that Red Hat and StackRox, Red Hat has purchased StackRox. Together, we cover a lot of these techniques as part of the platform itself. So, in terms of the container registry, in terms of authentication, in terms of hardened containers, we do a lot of that. It's built in as part of the platform of OpenShift. But there's a lot of things that we don't do. And so for the things we don't do, or we don't do very well, we depend on our partners. And one of our core partners is Synopsys, who helps us fill out this picture and do things that we necessarily don't focus on. And so I'll pass it on to Steve now to dig into Synopsys and the capabilities they provide for edge IoT deployments. Steve?
Awesome. Thank you very much, John. That was a great intro. So as he mentioned, there's a lot of great infrastructure in there that Red Hat has built up for you. And now we need to look at the stuff that you're going to put on it, and how do we secure that stuff, all the applications that are running at the different locations. So if you're not familiar with Synopsys, let me just do a real quick intro. Synopsys, our software integrity group within Synopsys, really has focused on building an overall holistic AppSec program for our clients and customers. We do a whole lot of things in the space. We're looking not just at a couple of point tools. We really want to make sure that you are building security into your processes, getting a very secure SDLC all along the way, understanding where the gaps are, and making sure that you're resourced from a skills and resources perspective. There's been a lot of talk recently about the overall software supply chain with the executive order, and this is one of the key areas that we're definitely helping people with, and we'll talk about that a little bit more in the talk today. And overall, you saw that picture of that overall DevOps flow from John, and there's a lot of purple Synopsys boxes in there, and that really is what we're trying to do, is building security into the DevOps cycle. Understanding the needs of both the development teams, the DevOps teams, and the security teams as well. So we want to maintain that velocity for the developers, while also making sure that everything is as secure as possible. I always like to say, why don't you put DevSecOps on here? But I just say that, well, DevSecOps is really just DevOps done right. And that's what we'll try to get through today, with a little bit of what can we do right to make sure that those are secure. People sometimes ask, what is the application and application security? And it's more than just the app on your phone or even a web app. The world really is all software. So when we say application security, we're trying to secure everything that could be considered code or software, which is basically everything out there now. And you saw that diverseness of all the different types of software, places where you develop, deploy, and try to secure those things within this edge and IoT infrastructure. So you've got the devices with some levels of firmware that's written in C code. You've got containers, you've got microservices, things are written in higher level or interpreted languages. You've even now got infrastructure as code, or even policy as code, that you're going to be able to take action on and ensure that the infrastructure that you're spinning up, or the policies that you're using to monitor your overall DevSecOps or DevOps processes are as secure as possible as well. So what I wanted to do today with that introduction was give a little bit of a primer, just introduce a few quick 4 steps of what you can do and what you should think about as you're developing your overall software security program for your edge and IoT systems. Some of this, I warn you, will sound rather basic, and I'm hoping that a lot of the seasoned security professionals, if they're in the audience, are looking at that and saying, well, duh, right? And these are all very basic things. But I'm not trying to, and I have a new favorite expression that somebody told me the other day, which sounds really weird, and I'm expecting everybody to Google it afterwards. I'm not trying to teach grandma to suck eggs. Very weird idiom that we have, but it's very descriptive. I'm not trying to teach the experts on how to do this, but I think there are some good reminders in here of what we need to be sure that we're thinking about and coming back to when we're developing our overall security plans. And I promise, if you bear with some of the basics at the beginning, I will get in step 4 some very cool and interesting technology that you may not be aware of. So let's start at the very beginning. And one thing that seems so obvious most of the time as we're developing a program, we want to understand what the system is and then how to secure it. People often overlook and skip past the idea of doing a threat model, looking at and identifying all the components and interfaces, what are the protocols. But it's very important to get all of this documented so that you don't miss anything later on. So many people, again, just skip through and start verifying or testing and securing things. Running analyzers just as soon as they type a line of code, which is a good practice, but a lot of times we want to step back and have that overall threat model that we can refer back to and make sure that we didn't miss anything at the end. So this is especially important. I've tried to simplify down some of the architecture that you've seen that can be very complicated, into identifying where are the boxes that have some code running on them. The IoT device, the edge endpoints, the analysis engines that are running in different places, either in the cloud or on your servers. And then there's the web UIs and the mobile applications. Then there are all of and each of those is written again in a different language. So we need to understand what each of those are, what frameworks were used for all of them in the languages. Then we need to understand all of the arrows in between, right? How are they talking to each other? The device is talking, via Zigbee or Bluetooth or Wi-Fi. If it's in a car, maybe it's actually talking over CAN bus. And then you've got some of the higher level application layers of MQTT. You've got HTTP. You need to understand each of those interfaces and the protocols and really fully test the robustness of each of those segments, which you can't do unless you identify them first and see where all of those attack vectors really are by doing a really complete threat model. And then also understand the use flows, right? What is the data? What are the APIs that are being used? And how are things getting communicated? What are the over-the-air updates? In the actual use cases. So all those things get built into a threat model. And certainly, if you've never done a threat model before, I highly recommend you get an expert, hire someone to help you do that. We're happy to help with that, either within Synopsys or with some of our partners. Or even if you've done these 100 times, it's always good to get that fresh set of eyes to make sure you haven't missed something too. So very important to get that threat model up at the very beginning, because that's going to drive the overall program from that point on. So the next point is really understand all the stuff that you're bringing in that you're not developing. So these are the frameworks, the base container images, all of the open source that you are starting with. There's a lot of goodness that comes with starting and using open source. 95% of projects today have some amount of open source in them, right? Because you don't want to reinvent the wheel. You want to have that good base. But with open source comes some risks, both security risks and license risks and operational risks. So we want to make sure that we understand those and then scan all the code to identify places where open source or other third-party code may have come in that we may not be aware of, and make sure that we're scanning at all the right places. So let's go into detail a little bit more on that. As we talk about the software supply chain, a lot of people will simplify that down to really just the open source dependencies. What's in my package manager file. That works certainly for some of the higher level web applications or languages that have great package management support. As we get into IoT and we start doing more low level code in devices, maybe in C, we don't have those package managers, and we need to be able to scan that proprietary code and look for signature matches and do other ways of matching, look inside the container images, and then understand and make sure that we're securing the infrastructure as code that's coming in. So there's actually a suite of tools and places where you inject these into that software development lifecycle to make sure that overall supply chain, right from not just some of the components that I'm bringing in, but my code, the resources that I'm bringing in, the images, the infrastructure as code is being set up properly, the API calls that are going out to different places, to public APIs, understanding what those are and are those bringing any risks in as well. So we'll talk a little bit more about each of the pieces down here, from a composition analysis piece, static analysis, as well as towards the end, we'll talk more about some fuzz testing, API scanning, and interactive application security testing. But the idea is to overbuild that user trust in your software application. A key piece of that is, again, that understanding the open source risks. So I mentioned a couple ways, making sure that you are doing detection in several different ways. You're not just looking again at the package managers, you're doing signature matching to find the things that people downloaded haphazardly. You're looking at all the container-based images that are being pulled in, and you're actually scanning all of your artifacts at the end and with a binary scan to make sure that things didn't get into the build process or that wasn't in, or the linking process that wasn't in your source code tree. So very important to have that multi-factor detection. And then you can, once you have that bill of materials, then you can work on protecting and understanding the vulnerabilities that are coming with each of those known components and versions. We know there are known vulnerabilities associated with those, but you also want advice on how to remediate them. So as you're looking for a good SCA or composition analysis tool, these are some of the things that you want to look for. And ideally, you've also got these license risks as well. I know we're focusing a little bit more on the security aspects here, but if you can find a solution that does the license risks just as well as the security risks and do them both with the same tool, then you make the lawyers a lot happier, and then everybody's happier. So be productive and kill, or get capture two birds with one stone, or so however the saying goes. Try not to kill things. And then the last part is managing that. So we want to be very efficient in our process, and we don't want to have to rescan everything all the time. We'd like to have that bill of materials and just get notified if there's a new vulnerability that pops up. So making sure that there's a policy in place and it can be automatically monitored for you. So when a new vulnerability comes in, you get notified right away. You can then very quickly see which customers are going to be affected by that potential vulnerability that came in from one of the components and one of the microservices that you're deploying to them. And even better in this overall flow is being able to have that already built into the OpenShift environment and the Red Hat infrastructure that John and Cody talked about. So Synopsys Black Duck has had a long-standing integration with OpenShift so that we can automatically scan, identify, and monitor the open source and all the container images that are being deployed in OpenShift. So this comes already done for you as pods spin up and images. You will get automatically notified. They get labeled properly, regardless of where they are or what that image is. You get that full picture. Speaking of the full picture, in that OpenShift environment, we've got that plugin into the API. It's already done for you, and the labeling of those makes it very easy to see where in which image or pod the various components, open source components are, and the risks associated with them. So once we've understood all the things that we're bringing in, we want to analyze all the things that we're developing, everything that we're touching. And so again, we're going to focus a little bit on that static analysis piece of the source code, whether that's the firmware, server code, app code, API code, infrastructure as code, policy as code, anything that has the as code in it is something that we're going to want to analyze from a static perspective. And There are a lot of static analysis tools out there. There are a lot of open source ones for various different languages. You know, one key productivity enhancement tool, though, is if you can support all of those languages, all of those frameworks with one tool and one methodology. So this is where Coverity's got a great leg up in this space. We are the leader in C and C++ analysis, as well as Java analysis and all these other languages that are supported. We also, have added support for infrastructure as code, so that you can have specific checks to make sure that you have a secure infrastructure environment. And the other piece is supporting any of the frameworks that you may have, whether those are specific checks for Android as you're doing your Android development, whether you are doing some AI work and you are coding in CUDA and you need those libraries to be understood and have some special checks for CUDA, or whether those are some of the Java or JavaScript frameworks, Angular, so that you don't have to reanalyze that code. You get a great productivity boost from both not having to reanalyze that and having models already pre-built of all of those frameworks, so it understands the data flow through them and where the sanitization happens, as well as reducing the number of false positives. So you get more accurate analysis when you have a better understanding of each of those frameworks. So very broad as well as focused analysis. You get the best of both worlds. So now I promised a few fun technologies at the end. So once you've done the static analysis, the composition analysis, and you've got you had your threat model already that's driving all the activities. The next thing is let's get it running and let's try to break it. This is really kind of that fun part, and hopefully you can do this in as few cycles as possible. The state space to try to break things and do verification and security testing is really infinite. So the more efficient that you can be in this aspect, the better off you're going to be. So we want to leverage that threat model as much as possible, understanding all of those interfaces, and really test the robustness of our implementation of those interfaces. This is one of the key attack surfaces for any IoT system. Is let's see if we can inject some errors or bad bits into the Zigbee stream or into the MQTT stream, or even just change the size fields in some of the internet packets. So let's fuzz all the interfaces and understand those models, all the APIs, and a lot of how you're deploying either on the edge or in the cloud are now at microservices, and we would really like to get a little bit more visibility into those microservices. So I could also talk a lot about just doing an overall pen testing, and that's something again that I highly recommend that you do, whether that's pen testing your web applications, doing a penetration test on your API test, whether that's your mobile applications, doing a pen test or a thick client test of some of the devices that you're putting into this IoT network. That's always a great practice, and we're happy to help with that. But here's a couple tips of some key technologies that you can do on your own. So if you haven't heard the word fuzzing before, it really is just delivering some unexpected input and observing the results. There are several different aspects of fuzzing, from and ways of doing fuzzing, everything from just flipping some bits. Actually, my first introduction to fuzzing was when I had a development manager tell me that he could break every piece of software with the orange test. And I said, okay, I'll bite. What is the orange test? And he says, I take an orange, I put it down on my keyboard, and I just roll it around, right? And you send on all this random unexpected input into the application. And in the old days, that really would break things because people hadn't thought to do this. But now we want to be a little bit more targeted, because just that random fuzzing is great for about the first 5 to 10 seconds, the first few packets that you send in. But the law of diminishing returns, happens very quickly right after that. So we'd like to be able to target specific protocols and file formats. We want to have a model built of those so that we can get into the nooks and crannies, into all of the different handshakes, and really cover that protocol. Get through the first 5 levels of handshakes and then introduce an anomaly, so that we can get deep into the state machines of the implementations of those protocols. So this is something that we have built out. We've done that investment of building out the models of so many protocols. We've got nearly 300 protocol suites. And in the IoT space, we've got suites for Zigbee, Bluetooth, flavors of Wi-Fi, 5G protocols, automotive Ethernet. We do have CAN bus, and then each of the application layer protocols as well. So for MQTT or HTTP, iSCSI is another one, NFS. The tool here is Defensix, and it built a name for itself, by finding the Heartbleed vulnerability so many years ago, and we really built on that. We're still finding 0 days and vulnerabilities in a lot of applications out there. This is actually kind of one of the more fun tools to go and do a proof of concept with too, because you get to send fuzzing traffic at a device and watch the lights blink and then turn off if things aren't implemented very well. But it is really meant to give you that productivity gain. It's very push button, and can help with, if you have any of these protocols that your device or your application are talking, I highly recommend that you fuzz them. The next piece is giving you a little bit more visibility. So if you haven't heard of interactive application security testing, it's kind of a weird acronym, but really what it is trying to encompass is that an agent-based technology that will give you more visibility than a static analysis or dynamic analysis can on its own, or bringing some of the static analysis visibility into the dynamic world, bridging that gap between SAST and DAST. That is what all IaaS technology does, but a really good IaaS technology will also do things like active verification. And this is a unique feature with the Seeker IaaS tool, which as soon as it sees any traffic coming in, may just be a normal access, it looks and sees, that's a transaction that's going to do a database lookup or a database write. And now, can I actually replay that with a fuzzed payload and try to expose some vulnerability? Very great feature that, for one, making sure that you reduce all the false positives because everything is actually reproducible with a real test case and example. And it also gives you that productivity gain of turning all of your functional tests into security tests. So you get this huge gain of, I didn't have to stop and think about what security tests to write. I didn't have to think about how to get past the authentication to target this one particular microservice. I've got that agent on that microservice already that can replay that transaction at that microservice level with a payload or a changed transaction, modified transaction that will actually expose a potential vulnerability. The other thing that Seeker can do for you from a productivity gain is, as you are instrumenting these different microservices, you can actually see how the data goes in between each of those microservices. And the tool will actually build out this map, this flow diagram for you of where the transaction comes from and each of the microservices it touches and where it goes within the infrastructure, and then where it goes out as well. So one of the key attack surfaces that we've also seen now is in APIs, and understanding where all of those APIs that you are presenting and calling is huge, and it really does also contributes to that threat model that we talked about at the very beginning. So the Seeker will actually, since it's instrumented on those services, it can see each of the endpoints that you're presenting and provide that full list, and you can see the coverage of those from the functional security testing. And then it also identifies all of the outgoing API calls and gives you a sense of, where are those calls going out to? Is that a public API? Is that an insecure public API that maybe I should really be worried about? So it gives you, so that's a great technology that really enhances that visibility and builds on the overall model. And then, of course, Seeker also fits very well. We've tested this and integrated this into various Red Hat environments, OpenShift, and just directly onto, RHEL runtimes, Red Hat runtimes. So it's already been proven in the Red Hat environments. It's ready to go. So again, very, very push button, easy to deploy, and gives you a huge productivity boost as you're securing your overall edge and IoT systems. So I'd love to talk more. There's so much more to talk about, kind of the next level. I think, maybe this would be the next webinar, would be talking more about how to integrate each of these pieces into a full DevOps pipeline, getting into your IDE. So being able to run some analysis in the IDE with CodeSite, both the covariate analysis and the black duck analysis, or also bringing all of the results together from all these different engines that we've talked about, as well as some others, into a single dashboard that can aggregate those vulnerabilities, deduplicate them, so that you have fewer things to in your queue, and then also prioritize them based on some machine learning techniques. So that's the code DX piece. And then how do we build that overall application security program? So would love to talk more about all those things at a later time, but just wanted to let you know that all those things are available. So just bringing it back together, just talking a little bit more about our Red Hat and Synopsys partnership. We've been partnering since 2016 with the Black Duck integration, of all the various partners that are working with Red Hat. We're very honored and humbled that we have been chosen as kind of that top application security partner in the space. So we're looking forward to continuing this partnership and helping make sure that as we're building out these technologies and helping our joint customers together, that it really is 1 + 1 = 3 as we put these together. Cody or John, anything else that you guys want to add on here?
No, I just like to say that we've had this strong partnership for a long time, and I think the issues that people are running into now with deploying software out at the edge, I think together we help alleviate a lot of those pains, and so glad to partner with you guys and continue to work together.
I mean, John says it all. I don't need to add anything on that.
All right, thanks, guys. So I think thank you. With that, we can turn it over to Q&A.
All right, great. Well, we have gotten a couple questions in, but there is plenty of time for questions. If anybody has one, just go ahead and use that question and answer tab there on your interface, and we'll go ahead and dive right on into what we've got. Okay, first question here is from Steve, who asks, I found one common problem so far for IoT. The user could forget changing the access control on the device, which left some backdoor for hackers. I know that this is more of a comment, but I know that this is becoming a pretty pervasive issue. So what do you guys, any of you have any comments regarding that?
Oh, go ahead, John.
Go ahead, Steve. Well, I was just going to say, I do see that as a problem. And I think one of the things in the industry and what has to happen more from a management standpoint is there a set of automation tools that I think will help with some of that, not all of it. And it depends on what kind of device it is, right? If it's a device that a user typically has access to, like a phone or something like that, I think it gets a little bit harder. But I think devices that are out in the field gateway devices, our sensor devices. I think there are lots of automation technology, and one that we have, our Ansible Tower, has that ability to automate some of these things to alleviate a dependency on an end user and relying on them to make sure they do the things the right way.
All right, great. Excuse me. Next question here is, actually, it's a follow-up from Steve. He says, one issue for IoT is it relies so much on the network, especially cloud computing. Examples like AWS down will cause even my fridge to not work. So what is your realistic suggestion for issues like that?
Well, what I would say is that what's happening when we talk about edge computing, what we really start talking about here is performing more of the analysis and processing the data closer to the edge so that you have less dependency on network. So yeah, certainly there will be certain things that have to be sent up to the cloud to be taken care of there. But this whole drive of edge computing is really about creating a platform from a Red Hat perspective, creating a platform that can run really close to where you're collecting the data, but then partnering or building software stacks that can run there, process data there. We are also partnering with a lot of OEM hardware partners for their technology and their edge and gateway technology to run close on the edge, to have more compute power, more storage in a more compact, ruggedized way so that you don't have to rely so much on the network. For the OpenShift technology, we can run in a disconnected model. We're doing some things with the Navy where you can run an entire platform on a submarine, right? Totally disconnected from any cloud access at all. So all of the technology that's being built around edge is being built with that disconnected, unreliable network model in mind. So I think what you'll see over time is that you'll have a lot more resilient computing running at the edge, and the network won't be as important.
All right, great. Just a quick reminder, guys, if you do have questions, please go ahead and get it on in. We have, I would say, about 10 minutes or so plenty of time for questions. Elizabeth asks, are there any particular security concerns we need to know about?
I guess it's a pretty broad question, and I think we've talked about a few of them. You really want to have that overall threat model and understand all of the attack surfaces. So depending on what the interfaces are into the device or the your edge compute side, the thing that I'm looking at quite a bit too is overall API security, which is really growing as an attack surface, and should be a key point of emphasis for anyone as they're because that's how we interact with everything. All of the compute services that are available, they're on the edge or in the cloud. And then so it's yeah. That's where I would go, and there's countless others. Any you want to highlight, John?
Well, along with the API as an attack surface, also, as I mentioned before, as you have more compute happening at the edge, encryption becomes more important for data at rest, because you may want to store some data on the device for those disconnected kind of situation, but also data in motion. So encryption technologies become more and more important as well, because now the data is living out here outside of the purview of a typical network. And so there's some definitely exposure there that has to be taken in consideration.
All right. Great, great, great. Okay, let's see. What else do we have? So many great ones have come in. Oh, here's a good one. And Steve, actually, I think you might be able to address this one. I think it'll be fun. What is your favorite or most interesting vulnerability you found in the IoT or edge space?
Ooh, that's fun. We found a lot of really, really fun things. You can find some really interesting things in static analysis. We had some Wi-Fi driver code as one example, with where we had a vulnerability that was a out of bounds access vulnerability that showed up only if you could trace through about 4 different files, functions going across the control and data flow, and there were about 20 preconditions in the control flow that had to be satisfied before it could actually get to that point. Things that you would just never see, like manually trying to go through those things. Another one in fuzzing, we went in and we were doing an iSCSI fuzz testing suite against a cloud storage appliance, and we set it up and kicked it off, and when we came back from lunch, about an hour later, we had completely bricked that very large and expensive cloud storage appliance. So it was a very clear proof of concept win. But actually, I asked this question of a development manager who was working on a self-driving car project. And I was expecting, that he would come back with one of those static analysis things of getting 20 different preconditions in the control flow. But he actually said the best one we found was with Coverity. There was a copy paste checker that fired in our code that where we're actually under certain conditions telling the car to turn right when it should have actually turned left. So just that simple copy paste checker, can have a huge impact.
All right. Excuse me. Well, we have I think one more question. So there is time, guys. If you do have a question, please feel free to go ahead and get it on in. Cody, this one I think might be best for you. How is Red Hat working with its partners to deliver on its edge and IoT goals?
Oh, that's great. Thanks. So Red Hat's partner ecosystem was kind of born in the open source community. I mean, that's where Red Hat came from, was open source. And so working together and fostering that ability to develop with other companies and to solve common issues is something that we're very used to. And I think going into 2022, we'll start to see a huge change where Red Hat pivots more towards our partner ecosystem and making sure that we best enable each other to work together. I mean, you see constantly, we're always looking for new partnerships and always looking to improve our ecosystem with Operator Hub and with our Ansible collection repository. And so Red Hat's constantly working on improving that.
All right, great. Let's see if we've gotten any more questions in. I think, okay. Actually, there is one more. Paul asked, on the subject of fuzzing, can Defensics investigate HTTP request smuggling triggers?
We do have pretty extensive HTTP suites, HTTP and HTTP2. I would have to dive in a little bit more and follow up on the specifics around smuggling, request smuggling triggers before I can provide an answer for that. But I'm happy to follow up afterwards.
All right, great. So Paul and everybody else who did submit questions, please know that the folks at Red Hat and Synopsys are going to get a copy of all the questions that came in. So if we didn't get to your question or if we need to follow up with you, as in the case of Paul, please know that it's going to happen. So we will definitely get an answer over to you. I will keep the question and answer tab open to see if we get any last minute stragglers. But the questions that did come in were some really good ones. So I do appreciate those who did submit questions. And just a quick reminder that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, please, you will be able to do so. So you can look out for an email that's going to be coming from us after the webinar. We will be sending out that email. It will contain a link to access the webinar on demand. We also do have the webinar living on the devops.com website, so you can go look for it there as well. Just go to devops.com/webinars and look in the on-demand section, and it will be there waiting for you. Okay, well, let's go ahead and I'll just do one final check of the question and answer tab. It looks like we don't have any more in, so I'm going to go ahead and do the drawing for the 4 $100 Amazon gift cards. Then we will call it a webinar. Let's see. Okay, our first winner today is Sanjay M. Congratulations, Sanjay. Our second winner today is Carlos M. Congratulations, Carlos. Our third winner today is Sean F. Congratulations, Sean. And our fourth and final winner today is Alan D. Congratulations, Alan. We'll be following up with all 4 of you offline by email to get your gift card over to you. So please check your inbox. And if you don't see it there, please check your spam folder. All right. John, Cody, Steve, thank you, all 3 of you, so much for imparting your wealth of knowledge on the topic of IoT and edge computing and security, and good stuff all the way around. Thanks for your time, and thanks for your expertise.
Thanks for having us.
Thank you.
Thanks very much.
You bet. You bet. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.